doing that to not have to teach math. Wait, that's what I'm doing in the video. So I guess it's the same thing. So, all right. So we're going to talk about solving linear systems with RREF in the calculator. And RREF stands for reduced row echelon form. Not that you have to know that. That's not going to be a quiz question or anything like that. But that's what the RREF stands for. And what it ends up doing is taking a matrix from a system of equations. And I think it's best that we just put a system up here as our first example. 8x minus 10y is equal to negative 20. And then negative 8x minus 7y is equal to negative 14. And, you know, in the recent past, we solved that by elimination. And this one looks like it'd be a really quick one to do by elimination. So it's a little easier probably to do the two variables with the skills we already have. It takes a little bit of time to put them into the calculator and then get it to do the answers. But for an obvious one like this, I would probably, if it were me on the ACT, I would probably just do this by hand and not mess with the calculator. But I want to teach you how to do it with the calculator so that when you get to one that's a little bit more difficult, maybe it is worth doing in the calculator. So this one, to put this in the calculator, what you've got to do is create what's called an augmented matrix. And we'll do a whole little set on matrices and matrix algebra later on. But this is, augmented matrix. What it basically means is take the letters out of the problem. Okay? And this augmented matrix will have 8, negative 10, and negative 20 will be the first row. The second row will have negative 8, negative 7, and negative 14. Notice how I've just taken the numbers that are in front of the variables, the 8 and negative 8, that's this column. Negative 10, negative 7, that's the second column. And then the last column is what the two equations are equal to. What form are these equations close to? Yeah, they're close to standard form, not necessarily following all the rules of standard form, but they've got X and Y on the same side. So it's just like you're going to do elimination. So if you're going to set up a problem to be able to do it with the matrix, you need it set up like you were going to do elimination. You got to have X and Y on the same side. Okay. Now, how many rows are in this matrix? Rows go across, right? Rows go across. 2. How many columns? 3. So the size is 2 by 3. That matters because we got to tell our calculator how big of a matrix we need. Okay. So 2 rows, 3 columns. Okay. Now, with the graphing calculator, what we want to do is go in there and enter this matrix into the calculator. So graphing calculator, we'll clear out stuff. The way to get to the matrix on the calculator is hit second, and then just above the X squared button is the X inverse button. Right above it in blue, it says matrix. So it's this button right here. So second, and then that button. Okay, right beside the sign button. All right. Now, you should be at this page. Should see names, math, and edit. Okay. Anybody not there? All right. Now, we want to edit a matrix and put the one we have for number 1 in there. So we're going to go over to edit. I'm just going to select matrix A, the very first one. It doesn't matter which one you pick. I'm just going to pick A so I don't have to hunt for it. I've already got one in there that's a 3 by 4. That's not the size of the one I need. I need a 2 row by 3 column. So I'm going to change that to 2, enter, 3, enter. Notice how it resized it for me. Okay. Now it shows a 2 by 3. Now I just need to put the correct numbers in there. And if you've already got things in there, that's okay. We're just going to type over them. So when I go to the first spot there, I need a positive 8. So I'm just going to type 8 and hit enter, and it replaces it. The second place is a negative 10. Hit enter, replaces it. Negative 20. enter, and then keep going. -8, -7, -14. Before you leave this page, make sure you've got all your stuff in correctly. Anybody not finding what we need? So let's go through those steps again of how to get there. We're going to second matrix, which is the X inverse button right here. And then we're going to go over to edit and pick a matrix to put it in. Make sure it's the right size. And then you're entering your information. It enters it by row. Okay. You got an X column, a Y column, and then an answers column. Next thing we need to do is go back to the regular calculator screen. So I need to get out of this and say by doing second mode, that will send you back to the regular calculator screen. Second mode, which is right beside second, that button. Then we need to tell it to do the Rref command. So to do that, we're going to hit second matrix. We want it to do some math with that matrix. So we're going to press over to math, and we're going to find the command that's Rref, which will be down toward the bottom. I press the up arrow to get down there faster. Rref is the one, not REF, but Rref. That's the one we want. Select that one. Now it says, okay, well, what do you want to do that to? Which matrix did you put in that you need that for? So I've got to go to the matrix menu and select the matrix. Second matrix. From the names, I'm going to pick the one I put it in. I put it in matrix A. So I'm just going to press enter. Close the parentheses and then hit enter. And it spits out a reduced row echelon form matrix. 1 0 0 0 1 2. What that means is from the original problems we had 8x minus 10y is equal to -20. This line says 1x plus 0y equals 0. Okay, pick your phone up again, son. No reason for that. You can't pay attention more than 5 minutes without checking your phone. Take it off your desk. Get it somewhere where you can't touch it. First equation, 1x, 0y equals 0. So that tells us that x is equal to 0. That's what this line tells us. This line says 0x plus 1y equals 2. 0x plus 1y equals 2. So that line tells us that y is equal to 2. So we have an ordered pair now. 0, 2. 1 and zeros, that's the reduced row echelon form. Okay. What's over here is going to be your answers. Always in alphabetical order. If they're answers, they'll be in alphabetical order there. Okay. So now all of that button pushing, we got the right answer. We got an ordered pair out of it. We could have gotten that pretty quick by doing elimination. So with two variable systems, it's not quite as handy, especially when you have one that's already ready to do elimination with. That's why most of the time I don't do them with a matrix. I just work them out because it's quicker. And time is a factor. You got to start getting faster at things. So let's look at this one. 9x minus 6y is equal to 30. 8x minus 12y equals 20. This one might not be as quick about solving if you did it by hand, because you got to multiply the first equation by -2 to get it to eliminate something. So maybe not as fast as solving. So this might be a better option as far as using the matrix stuff to solve this system of equations. So let's set this one up in a matrix. So I'm writing the matrix over here on the side so you know what yours should look like when you put it in. When you do these problems for practice, you shouldn't You don't have to write the matrix down. I'm writing it down just so you've got something to reference to when you go put that in, that it should end up looking like that when you type it into your calculator. So calculator, where do we go to get to the matrix? X inverse button. Yeah, the matrix second, and then matrix menu. Now where? Edit. Pick one. I'm going to use the one that's already the right size. So 2 by 3. It's already there. So I just hit enter and get into the rows. 9, -6, 30, 8, -12, 20. Okay. Now, check your signs. Make sure you didn't miss a sign on that, because if you just miss one number or one sign, it's an issue. It's going to cause it to work the wrong matrix. Okay. Second mode, to get back to the regular calculator screen. Now, here's where, since you've already done one, you can use a little shortcut to help you. You can press the up arrow until it's around that first where it says RREF, and if you hit enter right there, it's like a copy and paste. If you've got a TI-84, it'll do that. If you've got an 83, you can't do it. You got to go through the menu to get it to work out for you. So the RREF command, it says matrix A. It's going to do the matrix A that I put in there now. The other answer is from one that was in there before. Crank that out. We get 1, 0, 4, 0, 1, 1. 1, 0, 4, 0, 1, 1. What's our ordered pair? 4, 1. That first row tells you what X is. That second row tells you what Y is. Not too bad. Pretty easy, right? Let's look at number 3. -12x minus 8y is equal to 8. -6x plus 7y equal -7. Taking this matrix or this system of equations, and we want to put that into a matrix and solve it. Again, I'm just writing the matrix there so that you've got something to go by. Make sure you're typing it in the right way. 2 by 3 on this one. Second matrix, edit. 2 by 3. -12, -8, +8, -6, +7, -7. Second matrix, math, REF, and where I put that matrix was A. 1, 0, 0, 0, 1, -1. What's our ordered pair? 0, -1. How do I know that's correct? Plug it into one of the equations, right? Both. Got to work in both. Okay. So somebody first block said this. She said, well, this is pretty neat, because if I have to work it by substitution or elimination, I know I can work it this way and see if I get the same answer, which is absolutely correct. So you can always check to see if a system of equations has the same answer. No matter which method you use to solve it, you should get the same ordered pair if it has a solution. Okay. Let's look at number 4. 4x plus 5y equals 1, and 4x plus 5y equal to 4. All right. So this one, I think it's obvious what the answer is because of the setup of the system. But if we run it through the matrix, I want you to see what the matrix does for this. So I'm going to run RREF with this. So that's what the matrix should look like. So second matrix over to edit. I'm just going to use one, matrix A again. So 4, 5, 1, 4, 5, 4. And then I'm doing RREF on that matrix. And notice I get a decimal in there. Remember, we don't really like decimals. How do you get the calculator to turn a decimal back into a fraction? Math, enter, enter. So that will, within the matrix there, that'll change your decimal answers that it puts in there to a fraction, which is good. Might need that later on. But here's what we got. We got 1, 5 over 4, 0, and 0, 0, 1. That doesn't really give me an ordered pair, does it? This equation, the top row, says 1x plus 5 over 4y is equal to 0. The second equation says 0x's plus 0y's is equal to 1. Can 0 plus 0 ever equal 1? No. So this is a no solution problem. Anytime that bottom row has all zeros across here and then some other number there, doesn't necessarily have to be 1, could be any other number, but all zeros right there and another number there. 0 plus 0 can never equal 1. So we know that's no solution. If you did that problem with elimination and changed the signs of one of those, you see the x's and the y's all cancel out there. So you see that there would be no solution no matter which way you solve it. But I want you to keep note, the bottom row tells you what's going on. Look at number 5. Negative x minus y is equal to negative 6. X plus y is equal to positive 6. Put that matrix into the calculator. To me, this is an obvious one about what the answer is, because I can quickly do elimination with that one because I have opposites already. But let's look at what the calculator looks like when you do a matrix reduced row on that. Second matrix, edit, negative 1, negative 1, negative 6, 1, 1, 6. I'll run RREF on that. I'm just going through the long way of typing it in. And look at that matrix it gets you back. 1, 1, 6, 0, 0, 0. If 0x's plus 0y's, can 0 plus 0 equal 0? Always does. So that bottom row is true. So that's an infinitely many solutions. You guys didn't mind the 2 variables too much, but when we got to those 3 variable systems, that's when the work got really long and a lot of places to make mistakes, and it could get confusing pretty quickly. So with a 3 variable system, 3x plus 3y minus 2z is equal to negative 18. Will, can I help you, son? Are you? Well, mind you interacting with me, but you're not talking to your buddies while you're sitting there, especially when I'm talking. right? So we got 3x plus 3y minus 2z is equal to negative 18. And then we got negative 3x plus 5y minus 4z is equal to negative 10. And then the last equation, we got negative 3x plus 2y minus 5z is equal to negative 19. A lot of different ways to solve that, but ain't none of them fast, right? So if you try to pair up equations and eliminate, none of it goes fast with three variable systems. So what we can do is we can set that up into a matrix. What size will this matrix be? 3 by 4. You got three equations, so that's 3 rows. You got an X, Y, Z, and answers column, so that's 4 columns. So that's a 3 by 4 matrix that we're going to put that into. 3, 3, negative 2, negative 18, negative 3, 5, negative 4, negative 10, negative 3x, or negative 3, positive 2, negative 5, negative 19. So we're going to put that into a 3 by 4 matrix this time. So second matrix, go over to edit, and I'm not using matrix A anymore. I'm using a different one. I'm just using matrix A and changing the size to a 3 by 4. And then putting in my numbers. 3, 3, negative 2, and then negative 18. All right. And then the second row's negative 3, 5, negative 4, negative 10. And then the third row is negative 3, 2, negative 5, and negative 19. Be very careful. It's easy to make a mistake typing those in, mispunch a button, or forget the negative sign. So make sure all of your stuff is in there correctly before you leave that page. Okay. Once you've verified everything is in there the way you need it to be, run RREF for that matrix. And there we have a reduced row echelon form of 1, 0, 0, negative 3, 0, 1, 0, 1, 0, 0, 1, 6. If you didn't get those numbers on the end, you had to have had something mistyped into the equation. Now that's a lot better for three variable systems. It really is worth it on that to have this method for solving. So what does the first row tell us? It tells you the X. The second row tells you, and the third row tells you Z. So we get an ordered triple, negative 3, 1, 6. Just like we would if we solved that by elimination and substitution using those methods that we used before. Okay, so it really, really is helpful on the three variable systems. If you were to do reduced row echelon form for a three variable system and the last row ended up with all zeros and then a 7 over here, what do we know about that one? That'd be no solution. Doesn't matter what that number is over there, but if it's all zeros and a number, it's no solution. If it's all zeros, 4 zeros across the bottom, infinitely many. The great thing about the matrix reduced row echelon form is that you could increase the size of the matrix or the equations that you're working with. You could do 4 variable equations and you use a 4 by 5 matrix. You could do 16 variable systems and you would use a 16 by 17 out of that. So ever how many variables you have, you can, if it's a system of equations and it's linear, then you can use a matrix to solve it. If it's not linear, then that's where we're going to need those other skills that we've talked about throughout the unit for that. So easy stuff. You don't just got to get in the habit of doing that. I'm fine with you if you want to, when you go to do the practice today, you don't have to write the matrix out, just the ordered pair or ordered triple as the answer is absolutely fine with me. The word problems can even be done this way. You just got to make sure you set them up close to standard form, where X and Y or X, Y, and Z are on the same side. Make sure when you set yours up there. One other thing that comes up is if you had a system that maybe was 3x plus 2z is equal to 8, and then the second equation was 5x plus y minus 3z is equal to 10, and the third equation was negative 4y minus 5z is equal to 13. What do we put in for the matrix on that? This is, all right, so the first row, what's the first row of the matrix going to be? 3, 0, 2, and 8. Because what's missing? The y. So that column for the y's has got to have a representative in it. And since there aren't any y's, you put a 0 in its place. Second row, that one's straightforward. 5, 1, negative 3, 10. What's the third row? All right, and then you would just do your reduced row echelon form from that. Okay, so if there are missing pieces, you can still use the matrix. You just got to put zeros in those places. Make sure your variables are all on the same side before you start and in the right order. That order should be alphabetical order, X and Y, and the 3 variables, you got a Z in there as well. When you get your answers, if they're in decimal form, change them to fraction form. Math, enter. Okay. If you don't have a graphing calculator, we worked all these by hand, so you still should be able to get answers for them. So we're working on that.